It's a pleasure to be hosting this panel with such esteemed experts. So my role here is to kind of set up the stage so that the presenters can present their views. And I want to talk just briefly about what do we mean by infrastructure, and what are likely to be the key issues here. And in some sense, even though we could talk about shipping and air transport, the focus here is on land transportation, and in some sense that helps us focus on battery electric vehicles and fuel cell electric vehicles. So in terms of infrastructure, we are talking about the electricity grid or the hydrogen grid. And in some sense, what I want to bring out through this session is that it's not a question of the electricity grid versus the hydrogen grid, but it's both. And the real question is, where and how. And as you will see that a lot of the focus here is going to be on the US, but we would love to also get a sense of what's happening elsewhere in the world. Among our panelists, we also have policymakers from California and the US, so we'll get both the state perspective as well as the federal perspective. Now, in this, from the perspective of the issues, when you look at the infrastructure, we're talking about, as I said, the electricity grid. We're also talking about the hydrogen refueling infrastructure. And at the first level of resolution, the question is, what exists and what does not exist. And at that level, it kind of appears easy. If you look at the electricity grid, it exists today, whereas the hydrogen grid, it's in development. California, where we was the leader, even there we have less than 100 hydrogen fueling stations as compared to gasoline stations, which are close to 10,000. So from that kind of first cut, it looks like the electricity infrastructure is there, but hydrogen infrastructure is not there. But then as we dig deeper, we realize that if we want to do heavy duty transportation and we want to have the right infrastructure to charge these vehicles, even the electricity grid, the way it exists today, is not going to be enough. Because it's a different infrastructure. We need different transmission. Perhaps we need to have different kind of transformers. We will have to have different kind of chargers. Just as an example, even if you could use the fast chargers for light duty vehicles, which run at about 100 kilowatts, it might take a big truck to charge, using those, it will take a day. So we need to kind of go up to fast chargers that are running at about, 1 to 10 megawatts of capacity, and that will kind of, have implications for the rest of the grid. So at the end of the day, what it means is that even, whether it's a hydrogen infrastructure or the electricity infrastructure, we still need to talk about what needs to be developed going forward. And then there's questions around, how much money it's going to cost, who's going to pay, how long it's going to take. So at the end of the day, it's not a electricity versus hydrogen comparison and saying it's hydrogen versus electricity, but it's what is happening with both of them together, and what are the trade-offs and where one could be used versus other. So with that, what I wanted to do was to kind of move towards the panel here, and in our panel. We just briefly introducing the panel. We have two folks from Shell, Karsten Wellbrand, who is a senior principal scientist at mobility, and Raymond Bergman, who is the fleet electrification technology lead. Then we have Al Chafi from Plug Power. We have Patrick Huber, who is the chairman at H2 Energy. And then we have the two policymakers, Ben De Alba, who is at the California Electricity Commission, and Rachel Neeler, who is at the Department of Energy. So my hope was then, our hope was that these panelists will provide diverse views with Karsten Raymond talking more about technical issues and solutions. Al and Patrick talking more about business side of things, what are the business issues and business solutions, and then coming to the policymakers, Ben and Rachel, to talk about what are the policymakers thinking about. So I'll stop here, and we will have presentations by the panelists. The presentations by Shell folks, both Karsten and Raymond, are going to be about 10 minutes each. And then after that, I would invite Al and Patrick for 15 minutes each. And then we'll go finally to Ben and Rachel for 15 minutes each. And at the end of this panel, we'll have Q&A. As it has been mentioned, the Q&As should be submitted through the Q&A option at the bottom. And we'll be collecting these Q&A or the questions, and then I will direct these questions to panelists. I'll also request you that as you're writing down your questions, if you have a general question, it's fine. But if you wanted to direct your question to a particular panelist, please do so. So with that, I will hand over to Karsten at Shell to get us started.
Yes, thank you very much for the kind introduction. And let me share my screen with you. So hope it's coming. All right. Yeah, so thanks for the invite to talk about hydrogen infrastructure. And we have done recently a study to look into this in more detail, or another study, I should say. And yeah, let's get into matters. So first of all, about the supply chain and storage and transport. Obviously, the typical ways to store hydrogen that are typical today are compressed gaseous hydrogen, obviously 350 and 700 bar, liquid hydrogen, and yeah, another area we're looking in more from the research angle is liquid organic hydrogen carriers, which might have some interesting opportunities for the future. Now, if you look at long distance transport of hydrogen, clearly pipelines are the right way doing it. And here you can see that in several countries, there are already pipeline systems in place, mostly in chemical factories or refineries, but it's something that is used for many, many years. Now, for road transport, obviously, there are different ways doing it. So we have tube trailers, which can transport half a ton of hydrogen at 200 to 250 bar roughly. Container trailers, if you go to 500 bar on these, you can do about 1 ton per truck of transport. And if you want to transport more, it's probably the best way doing it in liquid way, liquid trailers, 1 to 4 bar cryo tanks on it, roughly 4 tons of hydrogen can be transported per truck. Yeah, so what are the ways to bring hydrogen to the refueling station? We might start here at the top left-hand side. So clearly, if your hydrogen refueling station has a gas grid, you can do steam methane reforming on the refueling station and get hydrogen from there. Even better if you have a pipeline, hydrogen pipeline access, so then it's easy to get connected to that pipeline, but that's probably for the longer term. Another way in doing is, of course, to have an electrolyzer on site of the refueling station and just produce your hydrogen that you need here from the power grid. If you don't have these options, the other options are going via compressed hydrogen with a truck that I already showed, or delivering it in a liquid form with a liquid trailer. Now, how does it look on a refueling station, and what are the key steps here? So the electrolyzer might be on your station, might be somewhere upstream, but then when you look at the refueling station, usually what you have is a low pressure storage system. And if you do this by trailer swapping is a clever idea here. So you might bring a full trailer full with hydrogen gaseous, and yeah, and take the empty one, the previous empty one with you, so you have a real good swapping system. You could have that in place. Now you will have to have a compressor here to compress your hydrogen from something like 200 bars, possibly here, to maybe up to 1000 bar, which will be needed for the dispensing. Yeah, another important piece of equipment here is a cooler, and the cooler is needed because you don't want to exceed your tank temperature on the truck, because with the dispensing of the hydrogen, temperatures go up, and especially when there's hot weather, you need to cool and pre-cool the hydrogen quite significantly. At the bottom, you see some numbers to give you an idea of well, how would a truck station look like versus passenger car stations. So a small passenger car refueling station would be probably with one dispenser. A larger one would have 4 dispensers, and with that one you could have a throughput of 1 ton per day, being able to refuel, to do 180 refuelings per day. Now if you look at a truck hydrogen station, and we would call that a small one, it would also have 4 dispensers, would probably be able to dispense 9 tons of hydrogen per day. You could probably do 110 refuelings if all the trucks were really empty. If they are not empty, it might be more. Refueling time, I think, is something like 10 to 15 minutes. I would say that's what we're working on. Towards 10 minutes of a full refuel seems feasible. Now we did a supply chain study to look into the different pathways of supply, and that is for the 2030 timeframe. I will try to get you through this without all the details, just to show you the pathways. So here we have a pathway which is called National Compressed Gaseous Hydrogen Pathway. So that would be a scenario or a case where there would be a central electrolyzer somewhere, maybe close to a big offshore wind farm or big solar field, so running on renewables. Then you would have to compress it to bring it to a hydrogen pipeline here. From a terminal, you would have to compress it one more time to bring it on a truck, say to 250 bar here, and then you bring it to the refueling station. The other option is here, local case. So local meaning the electrolyzer is on the refueling station. So you only have to compress, you have some storage on the refueling station, and then you go to the dispenser. Now we did calculate a pathway from North Africa, so sunny and windy place, low electricity cost, to Europe. And here electrolyzer, you need a compressor to bring it to the pipeline. Then you have probably like a 3,000 kilometers, so whatever, 2,000 mile pipeline at a cavern, in the end terminal, and bringing it per truck to the refueling station. Then 2 liquid cases we calculated. So national liquid hydrogen production, electrolyzer again, central, a liquefier, and then we transport all the way liquid to the refueling station. Here for the Algerian case, also liquid, we have a ship transport figured out, or a ship transport is calculated. And then again, all the supply chain to the refueling station. So these are some of the options we looked at in closer. First of all, looking into the efficiency of the pathways. And that is what you can see here. So in all scenarios, you basically start with 71% efficiency, which is due to the electrolyzer. So that's what the electrolyzer efficiency is by 2030. Currently, it's probably more in the 65% range, but by 2030, we think something like well below, maybe beyond 70% should be possible. You have your local case here, and the local means the electrolyzer is on site, as I said, of the refueling station. So you along the supply chain, you don't have a lot of losses, and that is why obviously the local case is the most efficient one. If you go to 350 bar dispensing, you are probably here. You don't lose a lot because the effort is not so big. But if you want to compress to 700 bar, you lose some more efficiency here because of the compression. This is a national case. Yeah, you use you have some more losses here because the supply chain is longer and you have longer distances, there's a pipeline in between, etc. For the Algeria case, here you have significant losses as well when you come to the very long pipeline, like probably 2,000 miles. You lose quite some energy here, and then you are in the somewhere mid 50, close to 60% overall efficiency. Now, if you go to liquid hydrogen, the big loss here is at the beginning, where you liquefy. Liquefaction is quite energy intensive, and you won't get that back. So in the national case, you have a little less losses to bring it to the dispensing. From Algeria, you have more losses because you transport by ship and you have boil-offs on the ship as well. Now, as we all know, efficiency is only one thing. It's important, but it's not everything. And even more important than efficiency is, of course, cost. And that is on the next slide. And you can see that here. Now, we have set the national 700 bar case on the cost side to 100%. So, yeah, we didn't put real cost numbers here because they vary very much, for example, with the electricity price. But basically, our base case, you can think of 100% here as something like, for the 2030 timeframe, yeah, possibly $5 per kilogram of hydrogen at the refueling, at the pump. So that's something which looks very feasible. Now, if you do this on a local basis, so you have the electrolyzer on the refueling station, you have higher cost, and that is mostly because the electricity is more expensive, because you are somewhere at the end of the grid, and it's simply more expensive, as if you were close to a say wind farm, offshore wind farm, where you could take renewable electricity right away. Interestingly, the Algeria case is at a similar level compared to the national production of gaseous hydrogen. So electricity is a lot cheaper in Algeria because it's sunny and windy, and renewable electricity can be produced a lot cheaper there compared to, say, Central Europe, which is this case. So yeah, electricity is cheaper, but then you have the longer supply chain and all the pipeline system, which creates costs. So you end up in a similar range. Obviously, when you look at liquid hydrogen, costs are higher, and that is because you have the additional losses by the liquefaction. So you need more electricity, basically, which is expensive, especially in the national case. So if you want to do liquefaction, you better do it in a place which is sunny and windy, like Algeria, and then you can bring the cost down. Yeah, I think on the next slide, I have a little cost breakdown of the lower cost pathways here. So again, the national 700 bar case, Central Europe. And you can see here that the production of the hydrogen is the most cost intensive part of this, due to the cost of the electricity and due to the high cost of the electrolyzer. And then you have the supply chain not adding so much cost. For Algeria, obviously, the cost for the production is lower because of the lower electricity cost, but then you have higher transport cost. This is a dark blue bar here, and in the end, you come close to the national pathway. Now, looking at liquid hydrogen here, clearly the liquefaction is putting quite a big chunk of the additional cost here. Yeah, then you end up somewhat higher here. Yeah, that gives an overview on where you could be. And again, the total numbers, again, have in mind something like $5 per kilogram is something where we probably hear. But yeah, every cent of lower power price here results in 50 cents less per kilogram of hydrogen. So there's quite some room for cost reduction still, if electricity, and especially renewable electricity, gets cheaper. Yeah, and with that, I hand back over to you, Girish. Thank you.
Thank you, Carsten. That was really great. Now I would like to invite Raymond Bergman, who is the Fleet Electrification Technology Lead at Shell, to provide his perspectives.
Yeah, thank you, Girish. Let me also share my screen. Let me share this presentation. Yeah, so I'm giving the sister talk of Carsten, my colleague at Shell. So I'm going to talk about e-mobility infrastructure for heavy duty transport. Again, the disclaimer that Carsten also had. Uh, and I'm showing this schematic to illustrate a little bit of what Shell has effectively on offer in this space. So this is a bus fleet, an electric bus fleet, as a matter of fact. And what Shell has on offer for these type of heavy duty fleets is charging solutions, so charging infrastructure, either in a private depot or in a public depot, and even en route, these can be placed. Also, the service of operating those charge points, so charge point operations, including the management of the fleet, how they charge, and also the loads across those chargers. But also the power supply can be arranged by Shell. So this can either be coming from a grid side, from production facilities, that Shell operates as well, or locally. And I think this is quite important that there are these options to generate power locally, either, for example, solar power, and also to store that power locally. And I think in the previous session, that was already very much illustrated and pointed out by the panelists that if you're operating a conventional fleet, there is almost a disconnect between the energy infrastructure and the fleet operations.
Hi,
On the flip
Raymond.
side,
One issue, we don't see the slides yet.
oh, you don't see the slides yet. Okay, I have shared my screen because I was actually talking to a slide.
Yes.
Uh,
If
share.
you'd like, we could. Okay,
Oh,
now we can.
okay.
Now we see
Do
it.
you see it?
Yes.
Oh,
Good.
okay.
Good.
So this makes a lot more sense, I guess, to the audience. Um, yeah, to return to what I was saying. So as was pointed out by the earlier panelists, there is a very strong connect for a specifically an e-mobility fleet between the operational mode and the infrastructure that you need, both the charging infrastructure and the energy infrastructure. And thereby having access to these local generation capabilities and also storage capabilities gives you actually more levers to play with. And that means that for an operational mode to satisfy a certain operational condition, you can actually have several solutions that will do that. So you can choose for charging during the night, charging during the day, and all of these will entail different charging solutions and energy solutions. And all of them will come at a price, and there is an optimal one for each operational scenario. So let me go to the next slide as well. Yeah, okay. Yeah, and that's why these local energy solutions, these behind the meter solutions, can be very important. They really help to control the energy costs and improve operations in that respect. They can also help to actually limit the costs of connecting this infrastructure to the grids, so defer and decrease in investments. Um, yeah, and that's really sort of what you get if you take a holistic approach across the grid connection, the energy infrastructure, the charging solutions, and the fleet operations. Around the charging infrastructure, I thought in this group it was interesting to mention some of the developments ongoing. It was already hinted at in the last panel discussion as well. So charging speeds are now for trucks around 250 kilowatt, is pretty fast. But in Charin, which is an industry body, we are helping to develop a megawatt charging system. And you can see there's a lot of industry parties, also a lot of parties that are actually represented here contributing to that. And this is a system that can charge at several megawatts of power. And I've highlighted here on the right, I've highlighted a number of aspects that I wanted to point out that are maybe somewhat interesting, that it's a single plug, so very similar to the charging system that people will know if they drive an EV. But also it has the say, the requirement of being automated. And I think this is interesting to point out that if we talk about the future, there are other technology developments ongoing as well. And I think you can't look at technology developments in isolation. So those should be considered as well. And self-driving technology is certainly coming up. And as was mentioned by the BYD represented as well, V2X will be a capability of this charging standard. So that means that the vehicle can also power the infrastructure itself. It can give power back to the infrastructure. And that means that as you're adding these heavy duty fleets with the larger batteries, you're actually adding quite a bit of power demand to the grid, which is effectively maybe destabilizing the grid. But at the same time, you're adding a lot of storage capacity as well. So if you have a typical truck of maybe 500 kilowatt hours of battery capacity, if you're adding this in a depot together with 20 trucks, you're actually adding 10 megawatt hours of battery storage at that location. And this is actually rapidly, right? This is almost at the scale of utility size battery storage that's being deployed at the moment. Yeah, this started in 2018 and it's ongoing. And actually a testing event has been held by NREL recently to test some of these inlets and connectors that comply with this standard. But following also the story that Carson was explaining, so if you have a charging infrastructure, you can power it by different means. So you can power it from the grid, which is a very typical solution, but you can use these local generation means as well. So you can locally generate power from renewables, or you can locally generate power from, for instance, gas. And in a study we did looking at the United States, we looked at several depots across different states, including California and others. And this is the result of that study. So here on the y-axis, you can interpret this as a sort of dollar per kilowatt hour. Here you have the years 2025, 2030, and these are the different means to power your infrastructure. So there's a grid solution. You see there's the cost of the energy, electricity supplied by the grid, the transmission cost, and the infrastructure cost, the real estate and the charging infrastructure. And then as the representative of Aragon Labs was saying, if you increase the utilization, you see the cost of the fixed components is going down, as you would very much expect so. And something else that is interesting to point out here is that actually for the cost of this infrastructure, the cost of this energy that you supply to the fleet, the major component is actually the energy cost itself. And this is different than if you had a light duty fleet, where the cost of the infrastructure would be a relatively much larger part of the total cost of supplying that energy. Local renewables, something like solar is taken here, has a very competitive cost. The thing is, it's intermittent. So if you want to really keep it local and want to avoid a grid connection, for instance, you will need storage. This will add a lot of cost. So in reality, you will combine this with other solutions like a grid connection to drive down the cost of this type of energy infrastructure further. And then natural gas generation is also a means to generate power locally. And you can do this either with regular gas or you can use biogas, renewable gas, and this can have this carbon index 0 is the indication here. So it can be supplied as a carbon index 0, which means that the production and the burning of the gas does not emit any CO2. And you see that that is competitive, and it's this scenario. So California is included here, which has quite high electricity costs. So it really depends again on the situation that you're in, what the optimal is. But you can see that that could be part of the mix as well, either with the solar combined to deal with the intermittency or combined with the grid supply. And that is also this is what I wanted maybe to conclude, is that if you're talking about infrastructure for zero emission vehicles, particularly electric vehicles, it's you have a lot of levers to pull, and it's very important to consider all those levers to come up with the best solution overall to supply this fleet. Thank you. So happy to hand over to the next speaker.
Yeah. Hey, thank you, Raymond. That was brief and to the point. With that, I would like to invite Al Chafi, who is the business development specialist at Plug Power. And I would also like to point out that now we are switching over to talking more about the business side of things. We heard from Carson and Raymond on technology, and now we're going to talk from the business perspective. So over to you, Al.
Thank you. Thank you, Girish. Hopefully everyone can hear me. And let me bring my presentation up on screen. So my presentation today, I will speak a little bit about Plug Power, give everybody a common background. We're probably the most successful company in the hydrogen space that many people haven't heard of, or maybe appreciate some of the numbers that we've been able to achieve. Those are significant because we believe that our experience in things like material handling space are a very good indicator of how the rest of the hydrogen economy and how some of these applications are going to unfold. So I'll talk a little bit about our business and how we see the vehicles operating, and then a little bit about infrastructure. So these are the numbers for Plug Power. We own about 90% of the market space in material handling. That is, material handling is a fancy way of saying forklifts and fork trucks that operate in indoor facilities, warehouses, distribution centers, manufacturing centers. You'll see the list of some of our customers there at the bottom. We have over 40,000, and that's as of the end of the first quarter of this year. That we're well into the second quarter. There are more than that are now deployed. We have over 40,000 units that are deployed and in operation. Those units have accumulated in their lifetime over 600 million operating hours. And we estimate plus or minus 100 million miles, about 1.4 billion miles traveled. That is an extraordinary number when you think about it. We buy and resell and provide to our customers 40 tons of liquid hydrogen every day. We have our own fleet of delivery vehicles. We utilize our suppliers' delivery vehicles. And the thing that I would like for everyone to understand about fork trucks is that they operate in many respects, much harsher conditions than passenger vehicles and on-road vehicles operate. There's no shock absorbers. So a fork truck will experience up to 40 Gs. In some cases, we've measured 60 Gs of shock, carrying an 800 or a 600 pound load and moving from the dock onto the trailer that is parked at the dock. You will see that kind of shock. We see all sorts of airborne contaminants. My favorite one is the rug distributor that has all sorts of fibers floating around in the air. That was very challenging to understand how to properly filter. We have a very good value proposition in the frozen food space and the refrigerated food space. So we will regularly see minus 30 degree Fahrenheit to plus 100 degree Fahrenheit changes within 30 seconds. If you go into the freezer warehouse, fork truck will pick up a load and it will, within 30 seconds, be on the dock. And if you're in August in a southern state, you're over above, even in a northern state, you're above 100 degrees. That happens within 30 seconds. So that's not thermal range, that's approaching thermal shock. We also experience rapid start-stops, which is not the case with an on-road vehicle. Even a delivery vehicle, like an urban package delivery vehicle, will make frequent start-stops, but not at the rapidity and not with the acceleration and deceleration that we see in fork trucks. So we believe we have very deep experience at making commercial vehicles that have to operate very, very often and have a very high power to weight ratio and making them operate in very harsh environments. So there's also a misconception as to what we do and why we do it, okay? We make a direct replacement for the lead acid battery or the lithium ion battery that goes into a electric fork truck. And you'll see here, I don't know if my cursor will show up, but you'll see here in the yellow dots, that is what's referred to as a class 3 pallet jack. That is a battery. That is a gen drive, a plug powered gen drive unit that replaces the battery. That's where the battery would sit, okay? It is a self-contained unit. It's got a fuel cell stack. It's got air handling. It's got a small battery for acceleration and for regenerative braking and for also lifting of the providing the energy to lift the load, and then on dropping the load, we also recapture that energy. It has a fuel tank in it. It also has a water tank, because the output of these fuel cells are heat and water, and we're operating in an indoor facility, so we cannot leave the water laying on the ground. So we have to collect the water as well. It is a drop-in replacement for conventional batteries. So the thing that I would like for everyone to consider and understand is that our customers willingly replace a perfectly good zero emission technology based on batteries with a zero emission fuel cell. And they've done it 40,000 times. This is not an experiment. This is not a trial grant that the CEC or CARB has put out. This is real money that real customers are spending, and they're willingly replacing one perfectly good zero emission technology with another. Why is that? And the reason is because we are able to demonstrate compelling economic value. And the way in which we demonstrate the compelling economic value is informative for how on-road vehicles and commercial vehicles will also travel along this path. And we've heard this throughout the day today. And this is Plug Power's experience. Our customers are highly protective of their data. In fact, this slide goes very close to getting them to the point of being perturbed, because they don't like for us to describe anything at all about their operational efficiency, because that's competitive advantages. But I've highlighted a couple of issues here. All right, long recharge times. That doesn't exist with a hydrogen fuel cell. It takes about 3 minutes to replace the fuel in this vehicle. There's no long operator downtime. If the operator is refueling the vehicle and it takes 3 minutes to refuel the vehicle, as opposed to 20 to 25 minutes to change out the battery to replace it with a fully charged battery, that's real productivity improvement. There is no drop off in performance throughout the shift. Batteries, as they discharge, the terminal voltage decreases. The terminal voltage on the output of our fuel cell is constant as long as there's hydrogen in the tank. Just like the vehicle, a diesel or gasoline powered vehicle, will continue to put out power as long as there's fuel in the tank. There's no capacity loss with aging in the environment. We're very, very good on working in wide temperature ranges of applications. Our customers will routinely report anywhere from a 15 to a 25% increase in labor and asset utilization. We had one customer tell us that they plan their new distribution facilities, their new builds, when they were deploying batteries, they would utilize a model of about 350 fork trucks that they would have to lease, and these are all leased vehicles that they would have to lease in order to fully complete the mission of that distribution center. When they switched to fuel cells, our fuel cells in particular, that number dropped to 250 vehicles. That is real money. And they do this, and they take advantage of the investment tax credit at the federal level, but there are no grants, there are no state grants that go into this. This is all real business case that the CFOs sign off on and say, yes, this is a good deal. So if I compare this experience to internal combustion engines and look at the kind of vehicles that we're talking about here, on-road vehicles, taxis, delivery vans, port equipment, drayage trucks, buses, even things like yard tractors and gantry cranes. If you look at the advantage that an internal combustion vehicle has over a battery-powered vehicle, the advantage of a battery-powered vehicle is in emissions. In all of the cases, the fossil fuel vehicle really has an advantage. But if you look at a fuel cell vehicle, the fuel cell vehicle very closely approximates the experience that you have with a fossil fuel powered vehicle and also has zero emissions. So our experience with these operational criteria here is that eventually this space will be dominated by fuel cells. Now, as people have pointed out, there is no one size fits all. There are plenty of use cases where battery operated vehicles will make plenty of sense. Certainly in the passenger vehicle range, where you have access to charging at home or charging when your car is parked, makes plenty of sense. There's no reason to not consider that. But we believe that as you go heavier duty and heavier use case, hydrogen has and fuel cells have a more and more compelling value proposition to make. So now let me switch to talk about infrastructure. Plug Power also, we design and install our own infrastructure. In the bottom right, you'll see a wide view of a typical refueling station that we'll install on our customers' locations. We have constructed and operate over 140 of these, and by the end of this year, we'll be well over 160. We've got at least 30, possibly 40 that we'll be installing this year alone. And these are considered mission critical. And if you remember to the first slide, we have customers like Amazon and Walmart, and you do not have unavailability of hydrogen fuel to these large distribution centers, especially during things like the Christmas rush. This is mission critical infrastructure, and we're very proud of the fact that we've never run a customer out of hydrogen. We always make sure that hydrogen is there. You can do this in any number of ways. You can have an electrolyzer on site. You can have delivered gas. You can have delivered liquid. All of them can be renewable and carbon-free or sustainable. You can do it any number of ways. I will say that of those 140 stations, all but maybe 2 utilize delivered liquid as the primary. In fact, all of them use delivered liquid as the primary. Some of them have an on-site reformer just for backup, and because there's high availability of natural gas or local availability of natural gas in an area. But delivered liquid is the delivery technology and the fueling technology that we have experience with, that says this is the most cost-effective way to go and is the most reliable way to go. So you may have seen this slide, and this came from the Center for Transportation and the Environment. I believe Jamie Levin put this together, and he talks about how battery electric vehicles are easy to implement at first, but they don't scale well, and then hydrogen infrastructure is difficult at first, and it gets much better over time. I tease him that I fixed this slide for him because in our estimation, this green line is that the initial costs to do this are much, much lower than have been portrayed. And we have the experience and the depth of deployments to back this up. And we believe that that crossover point occurs much sooner. Now, on the hydrogen side, and this is the last slide that I'll leave you with. This is announced public information. We are building a nationwide network of what we call a force majeure tolerant liquid hydrogen production capability. And you'll see the stars. 2 of those sites have already been announced, one in Western New York and one in Pennsylvania. The rest of them are pending various phases. By the middle of 2023, we expect to have somewhere in excess of 125 tons a day of liquid hydrogen production using 100% green energy. This will be a 100% green hydrogen production. And we also have thought about using fuel cell powered vehicles to transport the hydrogen. It would be a very bad look to have a diesel spewing, diesel belching tractor pulling a trailer full of nice green, clean hydrogen. So this planning is underway. We are making the investment and to do this. And the advantage of having these multiple dots across the country and having that interlock is that, let's say this plant here located in Texas goes down, we can shift delivery from these other dots and cover the outage. So it's very important. I mean, these are mechanical systems. They are designed with redundancy. They're designed to be reliable, but things break, and things break in unexpected ways. So we're making sure that we're planning the network so that the network itself has some degree of tolerance. And that concludes my presentation for today.
Well, thanks a lot, Al. That was very thought-provoking, and you do make a very compelling case for hydrogen, and especially in heavy-duty transportation. I'm sure there will be a lot of questions from the audience, including from myself. But with that, let's move on to Patrick Huber, who is the chairman of H2 Energy. And I would request Patrick to also talk a little bit about these challenges of heavy-duty transportation, especially the infrastructure side, and from a business perspective. So Patrick, over to you now.
Okay. Thank you very much for the introduction. I hope you can hear me well. I was just struggling before with the microphone, but I guess you should now be seeing my presentation. First of all, thank you very much for letting me part of this of the Stanford Hydrogen focus group. It's a privilege of being here, and also thank you for the previous speakers on their very interesting comments. I've learned a lot, and I even adjusted my presentation slightly because I had some overlapping comments which I could have not provided in the similar eloquence that had been done by the previous speakers. I will. Sorry, I will quickly talk about H2 Energy, make a quick introduction, then explain the cold hydrogen cycle, and have sort of a case study on the heavy-duty fuel cell truck model that we applied in Switzerland. It's a model that runs without subsidies, without grants, so it's simply commercially driven. And if time allows, I will also say something on the external costs, because we spoke a lot about costs in general, but we never included external costs. And I believe when we compare costs to the specific technology, we need to include them, because if they're not being allocated to the originator, it actually leads for the individuals to make irrational decisions, or decisions where they arbitrage the system. So I think it's a very important subject. First, on the introduction, I usually talk about hydrogen, but as I said, that was well covered. So what I wanted to talk about is why we're having this discussion here. Why are we discussing battery electric vehicles against the fuel cell electric vehicles? And the reason, and actually also why should fuel cell electric vehicles now all of a sudden experience that growth, which is projected by so many? Because the technology's been around for 60 years in cars, and the technology as such over 100 years. It's been used in space for over 60 years. So why should it be now? And usually the answer can be a very technical one. We talk about the degradation, about the stability of the fuel cell, how we reduce the platinum content, and how had a positive cost impact, or how we increased the scale, which also came with a positive cost impact. But the real answer to that is really the energy transition. And I believe that the reason why we have this discussion is because we want to decarbonize, because government said that they want to be CO2 emission free by 2050. Not every, but Europe did so. And when we talk about the energy transition, we don't only speak about making the electricity green. We have to speak about like replacing gas and oil and solid coal with green renewable. And you have a limited amount of renewables that you can use to get that task. And that's electricity, biomass, heat, and hydrogen. And with hydrogen, I include all the e-fuels on this. Now, the question is, what proportion will the individual renewables have? Because that's also going to impact then the decision on what application you need. If electricity is only going to be electricity, then you probably should be only battery. If it's only hydrogen, then battery has a less significant role. And we tried to come up with an estimate. And what we basically did is we defined the lower limit and the upper limit of the technologies, how they can evolve. And the lower limit is really given by the situation as it is right now. And how can we max out the proportion of that renewable? The upper limit is just the maximum that could ever be achieved. For example, in renewable biomass, you have a certain amount of acres that you can get biomass from on this planet, and not more. And so we assumed that we don't plant anything for eating or don't have any animals. We only plant for the purpose of biomass. and it would then get up to 38% of the electricity, of the energy that we need to decarbonize. But irrelevant in any way how you're going to turn it, left or right, you're going to be short 18 to 71%, which you need to replace by hydrogen or e-fuels. Somewhere in between, you know, maybe go for the arithmetic mean. And this consideration was really the consideration that we had when we founded H2 Energy. Now, H2 Energy is a small company with the goal to stop the climate change and establishing hydrogen as a pillar to the energy system. We're active in 4 fields. We develop fuel cell application for transport on land and on water, but also for stationary applications. We do engineering work for power to gas plants. We do engineering work for hydrogen refueling station, and we develop ecosystems, because everyone talks about hydrogen ecosystem, but nobody really thinks, or very few people think in ecosystem. We're self-funded, profitable, and free of debt, but I guess that's not so much of interest to anybody but us. And so I wanted to quickly talk about the first project with regards to the heavy duty. And it all started with Coop, which is the largest retailer in Switzerland, announced in about 6 years ago that they want to be CO2 emission free by 2023. So we approached them and we said, if you want to be CO2 emission free, you need to decarbonize your heavy duty fleet. Well, they said, well, we wanted to, but it doesn't really work because we've bought some battery electric truck, but they either don't have the payload or they don't have the range that we use. And we said, okay, we're going to build you a fuel cell truck. On this, they first didn't believe that we were capable of doing so, but once we organized that, we actually received some support from the Department of Energy in Switzerland for this trial phase. They gave us the okay. They also own petrol station chain, where we said we're going to build them a hydrogen refueling station, which was the first hydrogen refueling station in Switzerland. We then said, to actually complete the ecosystem, we need to have also green hydrogen. But Coop then said that they don't really feel comfortable in the upstreaming process. So we had to bring our own money. We bought an electrolyzer. We entered into a power purchasing agreement. We bought a trailer, which we used for the storage and for the distribution of the hydrogen to the HRS. And so we, in essence, we completed this small ecosystem, and we had a lot of information from having done so. By the way, it took less than a year to have it all completed. So the information we got is that the technology is working. That's very important. The second information is there is a high demand for that technology, that people, if they have access to it, they want to use it. And then we had a lot of technical data, like what's the degradation of the fuel cell? How does it work in the winter, summer? Is there any differences? But most importantly, we got the financial data on this. And what we realized in Switzerland is that we have a unique situation, that in Switzerland, you have a very punitive emission tax for heavy duty fleets. But if you don't have CO2 or NOx emissions, which a fuel cell doesn't have, you get exempt from that tax. And because of that exemption, we actually could offset the price for the truck, and we could offset the more expensive fuel price. So we realized that we sort of have a business model, because we have a similar offering at the same price, but without emissions on this. The problem was just how can we scale it up, because we didn't see ourselves in becoming a large truck producer, and Switzerland would not be a good location to start doing so. So we said we're gonna develop a model where we have control over the ecosystem, and the best model to do so is to have a pay-per-use model. How it works in essence is that the client, he pays a fixed fee per kilometer, and it includes everything except for the driver. So it includes service, maintenance, insurance, tires, hydrogen, everything, and at the end you get a fee per kilometer that you have driven. The amount, the charge per kilometer, is going to be calculated as a function of the size of the fleet that you're using, the expected kilometers you will be driving, and some specification on the truck which you require. And we also index that price to the gasoline price. So if gasoline price goes up, the rate per kilometer moves accordingly, and the other way around. So we start with this model. We actually now need the partners that we can really do this on scale. And to do this, we founded a joint venture with Hyundai. That sounds easy. It wasn't that easy. We literally went to every OEM on that planet and looked for a partnership to build fuel cell electric vehicle. But with Hyundai, we were very fortunate because Hyundai owns actually an extremely competitive fuel cell technology on this. In addition, we founded Hydrospider for the production of green hydrogen from renewable, and at a later point, Alpic, which is the biggest producer of renewable in Switzerland, and Linde, right now the biggest gas producer, joined that joint venture. And we also founded an association with filling station owners and logistic companies to this. So I will now quickly go into those three stakeholder roles. Now, the first role, the Hyundai Hydrogen Mobility Partnership, that's a European-wide exclusive partnership. We right now have 46 fuel cell trucks in Switzerland. Most of them have been rolled out to the client. The rollout started in October 2020. And we will start the full rollout in the second half of this year. We're going to have a capacity of 2,000 fuel cell trucks to be produced per year by Hyundai. And we now look to expand the model we have in Switzerland to other countries. It probably cannot be replicated the same way, but every country has certain opportunities that we look to build on a model that works for specific countries. This is how the truck looks. On the bottom left is the first batch of serial produced fuel cell truck, how they boarded. And on the bottom right is it's the first time that the truck refilled at the newly opened hydrogen refueling station in Switzerland. It's a 34-ton truck. Next month, we're going to get the 40-ton truck, and the tractor is right now in developing. Now on the Hydrospider, I referred to a link on YouTube to explain some details how it works. So basically, Hydrospider produces low-cost green hydrogen. We use what Carsten actually introduced as trailer swapping. We just call it container swapping. So we use the containers as storage and for the distribution of the hydrogen. We have PEM electrolyzers, which take the electricity before the meter. So we don't take the electricity from the grid. We don't believe in this. And then we put the containers at the hydrogen refueling stations and take the empty one home. Now, on the pricing side, we calculate that we need to match 9 to 9.5 Swiss franc per kilometer as a price to make a profit on Hydrospider, and the sensitivities to electricity and depreciation, that's really from our business plan. It depends on the size of hydrogen production, how the sensitivities move, but usually the biggest portion is electricity, and the larger the power to gas plant is, the more significant the electricity cost is, or the more sensitive to the electricity the hydrogen price becomes. So please keep the 9 to 9.50 in mind. And I come to the latest stakeholder, which is the H2 Mobility Association in Switzerland, founded with 7 petrol station chains that cover roughly 80% of the petrol market in Switzerland, and 14 logistic companies, 14 of the largest logistic companies in Switzerland, who have a strong demand for fuel cell trucks. We have opened 6 hydrogen refueling stations. They're all without any subsidies. They're all privately financed. And we try to cover first the northeast-southwest axis, because that's the axis which has the most traffic for distribution truck. And we have another 4 stations to be open in the next 4 months. So that and for 22, we're already working on an additional 8 stations where we can also tackle the north and south axis in Switzerland. And I come now to the most important slide, and that's should explain you why we need fuel cell heavy duty trucks. Because to match TCO parity with diesel, we need to get the hydrogen price at the pump at the level which is 7.73 times the price for a liter of gasoline. So if a gasoline liter costs 160, the hydrogen price cannot be more than 11.50 to actually achieve cost parity. And you need to have a margin for the HRS, because they need to get their capex back and their OpCos covered, and the margin for the hydrogen refueling station is somewhere between 1 and 3 Swiss francs. Now, the cost to run a hydrogen refueling station per year is roughly $200,000. And if your margin per kilogram is 2 francs or $2, it's almost the same, it means you need to sell like 95 tons, 95,000 kilograms of hydrogen to break even and have a small profit. Now, a passenger car uses about 130 kilograms of hydrogen a year, because on average in Switzerland, they drive 30,000 kilometers. So it doesn't really work, because you would need 750 passenger cars to break even on your rate race. But a truck actually uses 7 to 8 tons of hydrogen, and therefore you need less than 15 trucks to break even. So we're actually only using the trucks to build up a grid of infrastructure for production of hydrogen, but also distribution of hydrogen, because we can steer it better. It's a cheaper technology because we use 350 bars, and we can synchronously build up this infrastructure in Switzerland without requiring any subsidies. As expected, I missing the time for the external costs, but I'd like to thank you very much for your attention, and look forward to the panel discussion. Thank you.
That's wonderful, Patrick. This does make a case for hydrogen and heavy-duty transportation, and I'm really intrigued by your point about you can make it work without subsidies. So hopefully we'll come back to this in the Q&A. But now it's my turn to move to the policymakers, and we have all heard a lot about the technology. We have heard a lot about hydrogen, a little bit about kind of the battery electric vehicles. But with this, I would like to kind of go to Ben D'Alba, who is at the CEC, to talk a little bit about California's approach to electric transportation, which includes batteries versus fuel cells, and in particular focusing on heavy duty. And in some sense, I'm curious about this thought-provoking statement that Patrick made about maybe we need to use the heavy-duty trucks to create the hydrogen refueling infrastructure in the state. So with that, over to you, Ben.
Well, great. Thank you for that. A lot of exciting presentations already today, and so I'm very privileged to be among the panelists from earlier this morning and my fellow panelists right now. My name is Ben D'Alba. I'm an advisor to Commissioner Patty Monahan at the California Energy Commission, and she is the lead commissioner at the Energy Commission for transportation electrification and just transportation generally, as with regard to the work that we do at the Energy Commission. So there's a lot of exciting things that are happening out there in the world of hydrogen. A lot of that is happening and reflective here at the Energy Commission, and I'm going to touch on some of that, of those exciting things that we're doing at the Energy Commission. So we know at nauseam that the problem really is that transportation is the greatest and increasing source of greenhouse gas emissions in the state, which is why we're pursuing zero emission technologies. The emissions from the transportation sector account for over half of the state's GHG emissions inventory, 40% coming from the vehicles themselves, and then about another 10 to 11% coming from the production of the fuels to power those vehicles, totaling about 50%. So it's a major issue, and we're trying to tackle it head on. On the left here in the orange, we see that emissions from the transportation sector are actually on the rise, and that's partly due to increased vehicle miles traveled. We're seeing more people drive more miles than ever before. But at the same time, we are seeing reductions in our greenhouse gas emissions overall, mostly due to our advances in renewable energy in the power sector that has accounted for a lot of the reductions in the emissions thus far. So the solution, of course, it has to be zero emission, and it has to be zero emission in the transportation sector if we're going to improve and reverse the trend of greenhouse gas emissions. So with that, we have a suite of goals in the state of California to get us to zero emission. A lot of those recently coming from an executive order from Governor Gavin Newsom last year in September that put us on course for 2035 and 2045. As you see here, 100% electric sales of passenger vehicles by 2035. We want 100% electric operations for drayage trucks and off-road vehicles and equipment. And then by 2045, we hope to have 100% electric operations for medium and heavy-duty vehicles altogether. Now, we still have goals that we're embracing from the prior administration. We're shooting to have 5 million EVs sold by 2030. And then in 2025, we're hoping to have 1.5 million vehicles sold. We want 250,000 electric vehicle chargers installed and 200 public hydrogen stations. Here's a snapshot of the ZEV market today. And when I say ZEV, zero emission vehicles, this is passenger vehicles, and it includes battery electric EVs, plug-in electric EVs, hybrids rather, and fuel cell electric passenger vehicles. As we see, there's represented from the line here, the market share of zero emission vehicles has grown substantially since 2011, reaching just to about 8% in 2020. In blue there is the battery electric, green is the plug-in hybrids, and a small sliver at the top are fuel cell electric vehicles. We had about 1,000 fuel cell electric passenger vehicles sold or leased in California in 2020. All of these, I'll say, these statistics, anybody can find them available on our website. We have a zero emission vehicle data dashboard. You can find latest statistics on EV sales, EV population, the number of hydrogen fuel cell, hydrogen stations, and number of chargers. We're keeping a close eye on the global market. I think it's important to think in terms of hydrogen. We got to think in the global scale. We need a solution to reduce diesel pollution, and that solution has to be scaled globally. And that's obviously reflective of this workshop with several folks participating from across the globe. We see, based off our research here, we see a rather large uptick in the fuel cell population by 2025, led really by China and Japan and South Korea. But as of today, the stock, as we all know, is very limited and very small. But we are looking at this from a global perspective and want to prepare for this global transition to zero emission vehicles generally, but especially here for hydrogen. Okay, so the solution, again, is zero emission, and California has been a leader, and we have been leading for some time now, 30 years almost to be exact. Here's a timeline of the suite of regulations that we've had since 1966 with our first tailpipe emissions regulation. One I would like to note here is in 2009, that was the creation or the implementation of the low carbon fuel standard regulation, which deserves a lot of credit for bringing in low carbon fuels to the states, providing incentives at the upstream for producers and downstream for the end user to use the zero emission and low carbon fuels. So that has been widely successful and it's still in place today. Then we have, of course, the advanced clean cars. And then really relevant to this conversation is the innovative clean transit rule that the Air Resources Board has implemented for transit operators to move towards zero emission fleets. And now we have the advanced clean trucks rule, which will require truck manufacturers to sell a portion their vehicles to be zero emission, and that percentage will increase over time. But it's a huge market driver, and one that the Energy Commission is dealing from an infrastructure perspective. We want to make sure that there is infrastructure available for the adoption of these vehicles that are going to be required here in California. So how do we do that at the Energy Commission? Well, we have a program called the Clean Transportation Program. It's about $100 million a year, and we use that money to invest in grants and other incentives to really accelerate the adoption of clean fuels, and more so recently in zero-emission vehicle technology and infrastructure. We get the revenue sources are from vehicle license fees and some small abatement fees that we impose on our California drivers here. Now, I'm not going to dwell on this too long, but this is, I think, important to share. This is the light-duty network to date in California. We've got about 45. I think that is fluctuating between 45 and 47, depending on who you talk to. We're seeing over time here, from 2016 to 2020, increased demand for hydrogen. A typical light-duty fuel cell vehicle takes about 3 kilograms of hydrogen. We're seeing an average daily hydrogen dispense now about 2,800 kilograms, and I think we roughly equate that to about 1,000 vehicles are filling each day in California, which is great, and that's a growing demand that we see here over the year since we make investments. And I will add, well, 45 is the number at the end of 2020. We are projected to have about 179 hydrogen stations, getting close to our 200 goal relatively soon. We have a current solicitation or grant opportunity that has awarded stations in California, and we expect to fund about another 130 or so stations to get us close to that 179 number. Okay, so medium and heavy duty. We see this, I know this has been talked to at length here, but fuel cell trucks and buses offer some advantages over their counterpart. The battery electric versions, there's weight reductions, the refueling time is not as long, and they have extended range. Within that solicitation I was just referencing for the light duty stations, we're asking that the private developers that we're giving money to co-locate some refueling for medium and heavy duty vehicles at those light duty stations. And so 13 of those will be considered dual purpose. They'll serve both light duty and medium and heavy duty vehicles. Those are still in development. We haven't seen those actually be constructed yet, but it'll be interesting to see the results and how those function. The idea, of course, is to, if you co-locate, lower the cost, you bring the hydrogen to one location for a broader set of vehicles. And we have our sort of really first foray into the medium and heavy duty hydrogen area was a partnership with Shell in the Port of Long Beach. That's still going on today. I think we heard from a Toyota representative this morning, and that project is in place now in fueling some Class 8 trucks down at the Port of Long Beach. Okay, so why are we doing all this? Of course, zero emission is the way to go to reduce GHG emissions, but we're also seeing that there's some disparities going on with regard to transportation emissions, especially in low-income communities. As we see from this chart, the vast majority of those who are making under $20,000 a year are exposed or a greater exposure to diesel particulate emissions. And of course, that tapers down, but it's still a significant portion of those making under $60,000 a year are at greater risk of diesel emission exposure. And then if we look at it from a race perspective, our Black community is at a greater risk of being exposed to diesel particulate emissions because they are living in those low-income communities. And then Asian Americans and Latinos are follow-up. Okay, so the Advanced Clean Trucks Rule, as I mentioned in that timeline, this is going to be a huge driver, along with the governor's executive order, to bring zero-emission trucks and buses to the market, fuel cell vehicles included. The rule by 2030, we'll see that zero-emission truck sales would need to be about 50% of Class 4 to 8 straight trucks, and about 14% of all truck sales. So this is a huge driver, and we're doing a lot of planning to ensure that the infrastructure is going to be in place for these vehicles when they come to market. And part of that effort is a program we just launched. Actually, my boss, the commissioner, was at a press event today announcing our partnership with CalSTART to roll out a new incentive program for commercial vehicles. And this is going to provide a concierge-like program. CalSTART is going to lead. So fleet operators can come to CalSTART and get funding for their installation of infrastructure to support their zero-emission fleets. Hydrogen refueling is included. The program is called Energize, and it's going to jive well with some of the existing programs in the state. You have a Carl Morrow program that does a lot of vehicle replacements. The California Core is a vehicle incentive program for equipment. And the California HVIB is a incentive program for trucks and buses to get a rebate on the purchase of those vehicles, zero emission and low emission vehicles. So we at the Energy Commission have a program to support the infrastructure for all of these vehicle incentive programs that are in place today. Now, some of the exciting work that we're doing to progress the technology in the medium and heavy duty sector. The next couple slides that I'm going to touch on, this all happened within the last couple months. These are demonstrations that are sort of, I think, are really relevant and could have lasting impact in the marine and rail sector. On the left is a demonstration of a switcher locomotive that GTI is going to lead. The switcher locomotive is going to be repurposed. They're going to convert an existing locomotive to be fuel cell and hydrogen powered. It's going to operate at the port of West Sacramento. CalSTART is going to do a design of a hydrogen fuel cell powered tugboat, and then Golden Gate Zero Emission Marine is actually going to build a hydrogen and fuel cell powered passenger and patrol vessel. The Golden Gate Marine will operate here in Northern California, and then the CalSTART vessel, if it ever gets built, will be operating in Southern California. We awarded some funding to some transit operators. Sunlight Transit, obviously, many of you may already know, they're a leader in this space. They have a large fleet of, relatively speaking, of hydrogen buses. We awarded them some money to increase their fleet by 17 hydrogen fuel cell buses, and we're going to provide some funding for the infrastructure to fuel those buses as well. And then North County Transit, we recently gave them, in the same grant opportunity, some funding to add 25 fuel cell electric buses to their fleet by 2045. And so really excited to see that these buses are going to be added to the fleet and get the data and experience that we need to share those with other transit operators across the state. Now, just the other week on April 5th here, we announced some of the biggest grants that we've given out in the demo world for zero emission trucks and buses. This one is for trucks. Specifically, we partnered with the Air Resources Board, who's providing funding for the vehicles. The Energy Commission provided funding for the infrastructure, but the project there, number one, is for 100 battery electric drayage trucks that will operate in Southern California. And then the second one, proposal 6 there, is a project that will demonstrate up to 30 fuel cell drayage trucks. So we're really excited about these. These are really brand new. They haven't even been approved by the commission, but we are recommending award for these projects. And so a lot of excitement around these, and they'll be unfolding over the next couple of years. So I think I'm at time. I was going to get into some of the production side of things, but I'm going to leave it there and look forward to the conversation. Thank you very much.
Thank you, Ben. That was wonderful, and I hope you can get to some of your remaining material in the Q&A. Now, I would like to kind of go to our final presenter, Rachel Neeler, who is at the Department of Energy, and we'd love to get a perspective on how the U.S. As a country is thinking about these issues. So over to you, Rachel.
Great, thank you so much. Really appreciate being here today and making sure that my slides are being shown. All right. So yeah, thank you so much. I think this is a great 1-2 punch from me and Ben. I just want to note up front that Ben mentioned the ability for California to do regulatory and grant awards kind of in the same bucket. And so I just want to differentiate the Department of Energy a little bit. You know, at the federal level, we're largely in the grant bucket. We're not doing the regulations. We leave that up to our DOT and EPA colleagues in transportation. So that means that I get the privilege to talk to you guys about all the great research and development and the exciting things that are happening kind of on the cutting edge of research and development through the Department of Energy. So today I'm just going to talk very high level about the sustainable transportation strategy at the Department of Energy. So I'm a senior advisor for the transportation offices, and those transportation offices at DOE are the Vehicle Technologies Office, the Hydrogen Fuel Cell Technologies Office, and the Bioenergy Technologies Office. And so we really cover the full spectrum of transportation in those sustainable transportation offices. And DOE, through this current administration, a few things I want you to take away from this presentation. DOE, through this current administration, is investing in infrastructure and research, development, demonstration, and deployment to overcome technical challenges and address the climate crisis. We have a very specific decarbonization strategy for transportation that we've been working and getting our various stakeholders on board with. You know, this is going to require an all of the above whole government approach in order to address all the sectors that will require various technologies and fuels. And when I say an all above the approach, what I mean by that is not necessarily, you know, just funding everything and, you know, investing in everything. It's being very strategic about what we spend investment in, knowing that transportation has a lot of very broad requirements, but then very specific use cases, right? And so I'm going to talk a lot about the different use cases, especially in medium and heavy duty further along in this presentation. And medium and heavy duty and the corresponding infrastructure is really a key part of our decarbonization strategy for sustainable transportation, although there is no silver bullet. I will talk both about hydrogen fuel cell vehicles and battery electric vehicles. And one of the really interesting and compelling pieces about the medium and heavy duty market is the multiple uses, the multiple end uses, multiple applications, and not having that silver bullet, not saying, you know, we just want to electrify everything, or we just want to have fuel cell vehicles be the medium and heavy duty market. And then the corresponding infrastructure that goes with that, right? So there's going to be, we think, a mix of medium and heavy duty fuel cell vehicles and battery electric vehicles. So this current administration, really the focus has been, how do we address the climate crisis now? And the Department of Energy has our Secretary of Energy, Jennifer Granholm, who is really invested in this. So the focus we have and the charge we have in the coming months is really to put boots on the ground and focus on demonstration and deployment, because we need these solutions immediately. We don't have time to to continue just early stage research and development, we need the kind of back end demonstration and deployment in order to make these solutions available today and impact the largest, make it more accessible for the largest group of Americans, make it accessible for everyone. So our priorities in transportation and infrastructure to address climate change, you may have seen the president's plan for the clean energy economy. Here are the 9 key elements. This is very broad, a very overarching clean energy plan, but we now have a little bit more detail about what the priorities are in the clean energy economy, specifically with transportation. So I'm going to tell you a couple of the highlights, I would say, from the jobs plan that was just published, and it includes $600 billion in modernizing infrastructure, transit, rail, with major priorities in electrification. And I would say that that electrification is broad. It's not just battery electric vehicles, it's also fuel cell electric vehicles. $174 billion for the EV supply chain, tax incentive. There's a goal of 500,000 chargers, EV chargers to be deployed in the next couple of years. Also transitioning buses and the federal fleet over to electric vehicles. There's, I think, a little under the radar, but something that's I think a big opportunity, especially for fuel cell vehicles and hydrogen, is $17 billion in ports. There's a really interesting environmental justice angle to ports, knowing that they're oftentimes located near disadvantaged communities. And so this is an opportunity for us to clean the air, make those areas a lot more livable through clean electricity or hydrogen. And since we know that there's potentially an import-export play for hydrogen, you know, having those forklifts that Al was talking about at the port, moving things around and running on hydrogen that is being imported and exported is just a low-hanging fruit we see. And then we also have $100 billion in renewable power and grid investments. So that is going to be really integral to the transition to electric vehicles that are charging from the grid. And then we have $15 billion in demonstration for climate research and development priorities, including hydrogen. So we're really serious about making the investments in these technologies as soon as possible, and making sure that we're also providing, you know, one of the comments earlier in an earlier session, I believe, is not having kind of like one and done investments, making sure that there is continued innovation, continued research and development, so that we are able to continue to evolve the transportation sector, not just stick with the technologies that we have today and just deploying those. So transportation is really key. You've heard the investments that I just kind of rattled off, and Ben set up a lot of great reasons for why transportation matters to the public sector. You know, it connects people, it connects goods and services. It's actually one of the largest expenses in US households today. And we know it has surpassed the electric sector in the energy sector with the #1 source of CO2 emissions. So there's a lot of reasons to focus on transportation. And I'm talking about these billions of dollars amount, which is really incredible to even talk about investments at this magnitude. And really, as someone who has been in the field for a while, it is something that I think is very much needed in order for us to make this transition as quickly as possible. We have been working on sustainable transportation through those 3 offices: the Vehicle Technologies Office, Hydrogen and Fuel Cell Technologies Office, and Bioenergy Technologies Office. We've been working on these technologies for a long time now. We have about $800 million per year in research, development, demonstration, and deployment. And that is the kind of basis of what we have developed our transportation decarbonization solutions around. So the Bioenergy Technologies Office is focused a lot on drop-in biofuels, reducing the cost of biofuels using co-products as a means to lower costs, increasing sustainable aviation fuels. We have the Vehicle Technologies Office that has a significant amount of work in electrification, and even the on-road, medium, and heavy-duty sector, looking at reducing the diesel emissions and energy needed for medium and heavy-duty vehicles, so increasing the efficiency. We also have a lot of charging work in the Vehicle Technologies Office. And then we have the Hydrogen Fuel Cell Technologies Office, which has really been focusing a lot on the medium and heavy duty applications, and a new initiative called H2 at Scale, which brings together national labs and industry experts to accelerate research and development and demonstration of hydrogen production, delivery, storage, infrastructure, and end use applications. And so you can see that's a big umbrella of activities, but what we found was that hydrogen costs are really a key point to whether fuel cell vehicles are going to be a big portion of the transportation market or not. And so we're trying to figure out ways that in the very short term and the long term, we're able to drive those hydrogen costs down so that we're able to leverage that technology as much as possible. And so we have identified, so the medium and heavy duty sector really is a large piece of the puzzle these days. So it's about over 40% of transportation energy usage. And we talked a little bit about the light duty market. You know, electrification right now is a major priority for this administration to make that transition. You can also see it in a lot of the automaker promises of transitioning the light duty sector over to full electric vehicles by around the 2035 timeframe. We do expect there to be still some hydrogen fuel cell vehicles. You know, there are going to be applications that are in the light duty sector that are conducive to that market, and likely in pockets, like I said, maybe around ports or maybe different hubs. You know, California has invested a lot in the hydrogen infrastructure already. So California already has the majority of the fuel cell electric vehicles deployed. So there's probably going to be pockets of light duty hydrogen fuel cell vehicles in the future. But we're expecting and hoping that to decarbonize the full light duty sector, that we will be able to also meet a lot of the consumer needs with electrification. And potentially even biofuels, right, for the legacy fleet that is more difficult to turn over. But that still leaves medium and heavy duty. And like I said earlier, there's a lot of different end uses. So although it's, you know, over 40%, you can see that even that 40% is broken down into various components. And even within those components, heavy freight, light, medium freight trucks, commercial light trucks, air, water, rail, those are all very different applications. And so they're probably going to require different technology innovation and fuels. So it comes down to what are the biggest challenges in transportation for any of these technologies. And we are really focused around these main challenges, which are reducing costs of the alternative fuel vehicles, whether it's fuel cell electric vehicles, biofuel vehicles, or electric vehicles, and their resulting fuel or their infrastructure as well. And you can see infrastructure is its own piece because it is its own big piece of the puzzle here. And we also have a lot of focus on manufacturing and supply chain. So what is needed in order to increase the manufacturing needed in order to get the vehicles at scale? What are the supply chain requirements, the materials that that we need to extract. Where are we getting them? Both on the supply chain and the manufacturing side, there's a big push to build a more resilient supply chain and manufacturing network for the US. So making sure that the materials that we need are coming from the US and being built in the US. And then also providing jobs to US citizens and not even just US citizens, anyone that's living in the US at the time. So it's really important for us to kind of build that out. We also want to do so in a very inclusive way. So this is particularly important for us to not only build in a diversity of voices and perspectives in the research and development that we're doing, in the workforce that we have at headquarters or at the national labs, or the researchers through our funding opportunities. It's really important for us to do this in the most inclusive way possible, so that we're tackling all the various issues and problems and engaging with communities at a very granular level, so that we're able to identify the problems that are specific to that community and offer them some solutions, and have them come up with their own solutions and ask us questions about what might be a good fit for their community. And so then I said, I kind of left infrastructure to last because I know that this is the infrastructure panel. One thing before, so infrastructure is a bit of a chicken and egg problem at this point, right? So we have a lot of intentions to fund a national EV network, increasing the number of chargers. The government, the president has promised 500,000 chargers to be deployed for electrification. That'll likely be on the light duty side, but we talked a little bit earlier about what are the needs of medium and heavy duty infrastructure at this point. And so the chicken and the egg problem becomes a little bit difficult because, it's the, if you build it, will they come? And so, the government is really investing in a lot of this infrastructure, hoping to make this transition a little bit easier for consumers, and also for commercial entities as well. However, the infrastructure for medium and heavy duty, we don't know whether it's going to be 1 megawatt depots or 10 megawatt depots for electrification. Obviously, this is a place where fuel cell electric vehicles, as Al was saying, provide an advantage with the short refueling times, not having as much downtime to charge your vehicle, and really conforming a little bit more to the traditional model, the traditional diesel model that we currently have, which definitely has some of its advantages, but begs the question of, do we really have that many trucks that actually need to be driving back and forth across the country, and need to be refueled so quickly? Maybe we have, especially with the transition to kind of a hub and spoke type of business model, there might be some opportunities for electrification, pure electrification in medium and heavy duty vehicles as well. And don't get me wrong, I do not think that these technologies are in competition with each other. I think we need both because there will be these certain applications that are better for some than others. You might see, the heavier or the higher payloads might be more favorable for fuel cell electric vehicles as well. And as we continue to research and develop electric vehicles, that's also going to benefit the fuel cell electric vehicle system too. They share components. It's going to be a benefit for all. And I just want to end on kind of this one point that we do have a funding opportunity notice of intent to fund that we're really excited about. It is the 3rd iteration of our Super Truck program. And so although it doesn't focus as much on infrastructure, it does focus on the vehicles for, initially it was class 7 and 8 trucks in the first 2 super truck iterations. But now we're opening it up to medium duty and short haul and long haul, more regional applications as well, and really focusing on electrification and fuel cell applications as well. Previously, it was diesel vehicles and trying to increase their efficiency. And now we're really broadening it to different types of vehicles and using those alt fuels. So bringing it back to those initial administration priorities, you know, DOE has a lot of excellent expertise and technical background and experts, not only at headquarters, but also at our national labs on these technologies. And we're really excited about getting more involved in the demonstration and deployment of the infrastructure to support the decarbonizing of the entire transportation sector. So thank you very much for your time, and I look forward to the questions.
Thank you, Rachel. And I guess the first question that I had posed before you all started was, you know, can they coexist? And I'm hearing that there is a good case for the battery electric vehicles and the fuel cell electric vehicles to coexist. My first kind of, let me just open up the Q&A with a question to all of you, but I would start with Al. You know, we talk about this infrastructure, and this is something that Patrick had kind of started talking about. You know, who pays for the infrastructure? Is it private versus public? And what should be the sequence of this infrastructure? Do we focus on creating the infrastructure for the heavy duty vehicles first and then go to light duty, or vice versa? So Al, if you could just take a stab at that.
I would say that as long as we all still believe in the free market economy as a driver of wealth creation, it should be private sector, it should be customers that pay for everything. And we as suppliers need to figure out how to make it cost effective and a compelling business case. If we don't do that, none of this will happen. We'll have nice demonstration projects. We'll have nice papers. Stanford University will publish lots of nice information, but I don't see this getting any traction. I do want to echo some comments that Patrick made, and I think he is 100% correct when he says, and we've heard a number of people mention the chicken and the egg. I have morphed from appreciating that comment to loathing that comment. There is no chicken and the egg. They both coexist at the same time. Without a chicken, you don't have an egg, and without an egg, you don't have a chicken. I think Patrick is 100% correct in that you have to solve both sides of the equation. You have to be able to provide fuel all in with the vehicle, one price per usage, whether that's per kilometer or per time of day or per mile or whatever unit you want to use. That is the only way this is going to be broken. And I do believe that the comment that Patrick made, that you look at the number of heavy duty vehicles that drive adoption and creation of hydrogen as fuel versus the number of passenger vehicles, I believe the focus has been misplaced. If we really want to adopt, I mean, the way to think of this, and I know this is going to be controversial, anywhere where diesel is used, hydrogen makes a better case. Anywhere where gasoline is used, batteries make a better case. I think we understand how to get charges out to the masses. We don't understand how to get hydrogen out to the masses yet. And I think if you focus on, let's get rid of diesel, and how do you want to put your funding to work on getting rid of diesel, you'd focus on heavy duty applications.
Great. Thank you, Al. Patrick, did you want to add to that?
First of all, thank you very much, Al. I highly appreciate your comment. Yeah. Well, maybe 2-3 things. One of them is Switzerland is in a special situation because in Switzerland we're not allowed by the law to make deficit. So we can't just subsidize and grant to the extent we want. So we have to find other ways. So that's why we actually betting on having the right incentives, because the government has basically 3 ways how he can react. Government can make laws, the government can subsidize, and the government can make incentives, they can make regulation. And I believe the best driver for hydrogen case is if you make hydrogen bankable, if you put the incentives in a way that you have a commercially viable case, if you have less charge on the environment, because then you don't only depend on the government, but you actually get the whole financial markets, which is much larger than what the government can do. So we're quite critical on this, and I believe the market is more effective than top-down decision, and I think the market should decide which technology is being used in what space. When it comes, and I need to correct this, when it comes to subsidizing, I believe we need to make a distinction between invention and innovation. I believe invention is very good if the government has control, because then you create an asset which a lot of people can use and build on this. But with the fuel cell, we're in the phase of commercialization. We're not an invention. We're not even an innovation anymore. This is commercialization. And I think in that phase, you don't need subsidies. Then you need the market. That's my personal view. Sorry.
Great. Thank you, Patrick. And I would like Ben to take a stab at this question as well. But Ben, when you're kind of adding to what Al and Patrick just said, there was a question from the audience. I want to tack on this question on, what's the priorities for infrastructure funding for California? And we heard a lot about, the downstream and the midstream part, and which is the focus of this panel. But if you could also kind of talk a little bit about what's happening on the production side, and what does the CEC sees as the best mechanism for that as well. So over to you, Ben.
Yeah, great. So thank you for the question. It's not so black and white, I think, from the state perspective on who pays for the infrastructure. In some cases, like for example, we're mandated to fund light duty stations up until there are 100 of them publicly available. So we're doing that, and we're putting $20 million a year towards the deployment of light duty stations. Now we don't have a similar requirement for the heavy duty side, and it gets a little more murkier because you're talking about a lot of private enterprise, and should the state have a role in subsidizing some of this activity from the private enterprise perspective, fleets, transit operators, and others, and so forth. But there is a role for us to make sure, the end goal obviously being zero emission, and if we want to enable this technology to flourish in the state, then we do need to pay for some of this infrastructure. And the refueling is the more public-facing part of the infrastructure, and so we're thinking about, okay, well, how do we structure our investment programs to make sure that the market can get to a point where it's sustainable on its own, and then ultimately wean down and wind down the public subsidies for this type of infrastructure. So we're thinking through that now, and what sort of mechanism that may take form is yet to be seen. And the governor has put a proposal in front of the legislature to put about $1.5 billion in zero emission infrastructure, $1 billion, that would put a substantial amount towards medium and heavy duty. So we do see a need in the near term to continue to subsidize the deployment of at least the fueling stations. Now, when you look at the production side, there's a lot of upstream that would need to take place too to support the volume of hydrogen that would come with the increased population of fuel cell vehicles, and that also gets a little complicated. And how much does the state play a role? Our utilities, are they paying for some of the cost of transmission and production of renewable hydrogen? So it's hard to say, but for the foreseeable future, yes, the state, especially the Energy Commission, should have a role in deploying some of this infrastructure. Our priorities, now it's kind of, again, it's the same message that, look, we're not competing or putting battery electric technology against hydrogen. We want to make sure both have a chance to flourish, and that the duty cycles are really what dictate which technology gets adopted. So that's a priority that we're embracing. We have a ZEV market development strategy that our governor's office has put together that really kind of tries to coordinate all these multi-agency priorities in this sector. In addition to the market development strategy, I would say the priorities are really dictated by the goals that we have in place, and those are coming from the governor's executive order to really deploy, to phase out the sale of ICE passenger vehicles and trucks and buses ultimately by 2045. So we've got to, play a lot of catch up on the battery side, but start thinking about, okay, what does a network look like for hydrogen fuel cells?
Great. Thank you. I wanted to kind of connect this discussion to a question about what is the role for utilities, whether it's electric or gas, or even large companies like Shell in contributing to this refueling infrastructure. So I would like to direct this question towards Rachel to start with, and then go on to Karsten and Raymond.
Yeah, thank you. I mean, I think there's a huge role for utilities to play here. And I think if we don't have them with a seat at the table, this is a missed opportunity. And so I think there is a lot of, there's actually a lot of key stakeholders that need to be pulled into this for electrification. I'm sure also for hydrogen distribution as well, right? And so I think this is the larger group, and maybe that's the part of the role of government, is to pull these stakeholders together in order to create a solution that is optimal for the most people. And that is something that we're working on right now. And one of the ways that we are working on that is by first establishing very close working relationships with some of our counterparts at other agencies, right? And once we have a very clear vision at the federal level of how we can execute this, and figure out which of the stakeholders we need to bring in, that's how we can kind of pull this all together. So that's, I think, definitely part of the plan. We are not suggesting that any of these investments, especially in the billions of dollars, should be made without the relevant stakeholders at the table. Like, we need this. This is a very big request that kind of supersedes any type of single project that we've funded before. So we really need lots of engagement, and hope that as one of the government roles we can play is to bring all those stakeholders together and share those lessons learned.
Yeah, that's great. And I think this goes directly into what the follow-on I had for Karsten is, what role could Shell play into this? Because, if you look at the gasoline infrastructure, it was to a large extent set up by petroleum companies, right? Like Shell. So what role do you see in Shell playing in setting up this infrastructure?
Yes, thanks for the question, Girish. And clearly we at Shell have a clear commitment to become a net zero company by 2050. So that's a very clear commitment. And I think a year ago we called it still an ambition. Now it has been renamed as being a target, really. So it's clear we have to go that route. And we are investing already in both electric mobility and charging, as well as in hydrogen. And we really see this, that we want to be there end to end. And end to end means we start this in investing in offshore wind farms, big projects, in setting up electrolyzers. First one is going into operation, I think, within the next month. Several big electrolyzer projects are being announced in the 100 megawatts and even in gigawatt scale towards 2030. Yeah, and then all the supply chain of the hydrogen until to the refueling station is what we have planned clearly, and we also do have already hydrogen stations in place for passenger cars mostly. The economics do not look very well at the moment because there are not enough cars there. So in that sense, I think the heavy duty sector looks more attractive, because what was also shown before, the takeoff by a truck is, numbers higher than by a car. So the economics can be a lot more attractive.
Okay, great. I recognize that we have come close to the end of our official time, but if you don't mind, I'll take a few more minutes to kind of at least try to get a couple more questions answered. One of the questions that came up in our conversations, and I'm kind of digging a little deeper from this high-level conversation, and this is a question for Raymond. In your cost comparison among energy supply for mobility, you showed the price difference among different energy sources, right? But we didn't get to talk about the CO2 or the carbon dioxide impact among the different options. And this also connects to something that Patrick had started to talk about, the externalities. So perhaps, Raymond, if you could get started on answering this question on the CO2 impact, and I would love kind of Patrick to come in on the tail end to talk about a little bit about externalities.
Yeah, certainly there is. Thank you. So yeah, renewables have the lowest CO2 footprint of the solutions that I talked about. Other solutions I mentioned were connecting to the grid. So there you can, with PPAs, you can actually mitigate the CO2 footprint of the existing grid as well. So you can actually take action on that. And I also showed natural gas. And there was even a question of somebody saying, why do we talk about natural gas in the context of zero emission vehicles? But I think it's about the system approach, right? So if you want to electrify a fleet, you have several depots, and every depot will have a number of solutions that are possible and solutions that are optimal. But some depots, the solution space is very limited. So if you are in a city, you will maybe not have access to sufficient grid connection, right? The grid just is so overtaxed, also with all of the other electrification initiatives ongoing, that you don't have that. Even though that at other depots, you can actually place those grid connections and get that renewable energy in, or you can put that solar on. And there I think gas is actually a very good solution to enable it. And that's also the viewpoint of Shell. So gas is very much a transition fuel, and it is better using gas to displace diesel, or not being able to do this is certainly much preferable. So that's how I was looking at this. Yeah.
Thank you so much, Raymond. Patrick, you want to basically, we will end the session with you. So on externalities.
Oh, what an honor. Thank you. Yeah, well, just maybe to summarize what I wanted to say with the externalities. There are two studies out there. One has been done by the Swiss Department of Spatial Development. So that's an independent department. Not biased to one or the other technology, and the other one is by the EU Commission. I'm not sure which DG that's from. I believe it's DG Mobility, but I'm not sure. They basically came to this similar result. The EU Commission was about 600 pages, and the Swiss report was only about 100 pages there. So what they've done is they segregate the impact of the externalities in four fields. They say damages to nature and landscape. That includes segregation of natural habitat. They included air pollution, which leads to climate change. Then excessive noise and congestion costs. And then serious accidents and casualties. So, and they broke down in more smaller pillars, and they allocated the cost that was triggered by different transportation media, and then they came up with the result, which is, as I said, very much in line from both studies, that it's about 10 cents per kilometer ton. So if you have a 34-ton vehicle, that means per kilometer you drive, it's about 80 cents. It's about almost it's like $3.6 per kilometer. So now some of those costs, they can be mitigated with a different technology. Some of them can't. If you get run over by a truck, which is an accident, you don't care if it's a fuel cell truck or a diesel truck. It's same cost, you know. But air pollution is different, and damage to nature is different, to the extent noise as well. So what we did is actually we tried to quantify the impact of fuel cell, and we said that we can reduce with the fuel cell technology, if it's green hydrogen, the external costs by half. So that means roughly by $1.8 per kilometer for a 34-ton truck. So but the investment that it would take, is much less than $1.8, because in Switzerland the tax is for a 34-ton truck is about 70 cents per kilometer, which is a lot, but it's less than half of what you could reduce the external cost. And I think this will be a very powerful tool if we allocate the external costs. It's not an easy one, and you not only make friends, but I think that's the one with the biggest leverage.
Well, that's great, and I think that connects to the LCFS in California. But I'm sure Ben has a lot more to say on that. But we have run out of time, so I really wanted to thank you all for being on this panel, and I really wanted to thank the panelists for their expertise, and I look forward to working with you in future as well. So thank you again, and I appreciate you joining. Bye for now.